Hello students, I am Vishwanath. Welcome to my YouTube channel. Today's topic is force on a charged particle or Lorentz force. You know that a charged particle can be experienced force by two factors. One is by electric field, and it already discussed in Coulomb's theorem. Okay, and another is magnetic field, and due to its own motion through the magnetic field. These two forces can be known as Lorentz force. First, Lorentz force are two types. One is force to an due to an electric field. It can be expressed as Fe is equal to Q into capital E vector. Capital F force vector, this Fe denotes the force on a charged particle due to electric field. Small e denotes the force caused by electric field. This is equal to charge, amount of charge into the electric field strength. Okay, it can be derived from Coulomb's theorem or Coulomb's law. And another force is Fm, and it is experienced by the charged particle due to its own motion through the uniform magnetic field or through the magnetic field. Fm or force is equal to Q into B vector cross B vector, B vector cross B vector. Here Fm is the force due on a charged particle due to an uniform magnetic field, where B vector is the uniform magnetic field and B vector is the velocity of the charged particle, and Q is the amount of charge of the particle. Okay, therefore the resultant force on the charged particle is F vector is equal to Fe plus Fm. Okay, now putting this value, we can write capital F vector is equal to Q whole into E vector plus B vector cross B vector. Here Q is the amount of charge, capital E vector is the electric field strength or electric field intensity, B vector is the magnetic field intensity, and V vector is the velocity of the charged particle. Now I shall discuss these two forces in details. Let OX, OY and OZ are three mutually perpendicular axes. B vector, that is magnetic field, acts along the OZ axis. A charged particle having charge Q moves in a OXY plane. Okay, see, in this case it is a special case. In this case the B vector and V vector, that is the velocity of charged particle and the magnetic field, are mutually perpendicular to each other. That's why here cross product V cross B is equal to only VB. Here sin theta tends to sin 90 degree is equal to 1. The force acts on the charged particle due to the magnetic field is Fm, which is normal to both V and B. You know that the product of the two vector cross product or vector product of the two vectors is mutually perpendicular to the plane containing the previous two vectors. That's why the F vector, that is force, is normal to the plane containing B vector and V vector. Therefore we can write Fm is equal to QVB sin 90 degree, magnitude of Fm is equal to QVB sin 90 degree is equal to QVB. Okay. Now, since the force on the charged particle is normal to the velocity of the charged particle, that's why the charged particle moves in a circular path. This is the path of the charged particle. This charged particle moves in a circular path. You know that in a circular motion, the centrifugal force or centripetal force acts normal or to the normal to the direction of the velocity of the particle. That is, in a circular path, the velocity of the particle acts along the tangential direction and the force acts along radial direction. That's why the motion of the charged particle is circular. Now I am going to find out the frequency of the charged particle. This frequency is known as cyclotron frequency because in the cyclotron this principle is applied. Let r be the radius of the charged particle and m be its mass. Therefore, we can write that Fm is equal to mv square by r. You know that centripetal force is equal to mv square by r. Therefore, putting the value of Fm or the Lorentz force due to magnetic field, we have QVB is equal to mv square by r. This gives mv is equal to qbr. You know that mv is equal to the linear momentum of the charged particle. Therefore, p is equal to qbr, where p is the linear momentum of this charged particle. We know that kinetic energy of the charged particle or any particle Ek is equal to p square by 2m. Therefore, the kinetic energy of the charged particle is q square b square r square by 2m. Okay. And what is the work done by the charged particle? There is no work done by this charged particle. Why? Because the velocity and this direction of this velocity and direction of displacement of the charged particle is normal to the force applied on the charged particle. That's why this force is a workless force or no work force. That's why the work done by this charged particle is zero. Okay. Therefore, the potential energy of this charged particle is also zero. Therefore, the total energy of this charged particle is equal to its kinetic energy. This is equal to q square b square r square by 2m. Okay. Let omega be the angular frequency of this charged particle. Therefore, omega is equal to v by r. You know from circular motion that v is equal to r into omega. Therefore, we can write omega is equal to qb by m. This is the angular frequency or angular velocity of this charged particle. Let n be the linear frequency of this charged particle, and you know that n is equal to omega by 2 pi. Therefore, n is equal to qb by 2 pi m. This is the linear frequency of the charged particle. This is also known as cyclotron frequency because in the cyclotron instrument we can accelerate charged particles by this formula. And you know the time period is reciprocal to the frequency. Therefore, time period of the charged particle t is equal to 1 by n. Therefore, t is equal to 2 pi m by qb. You can see that the angular frequency or linear frequency or time period of the charged particle do not depend on the radius of the path or radius of the circular path of the charged particle. Now let the angle between B vector and V vector is theta. This is the general case. Therefore, we can resolve the velocity vector V vector into two mutually perpendicular components. One is V cos theta along B vector and V sin theta normal to B vector. Now, V sin theta is normal to B vector. That's why due to the V sin theta, the particle moves in a circular path in this way. Okay, due to the component velocity vector V sin theta. Due to the component V sin theta, the particle moves in a circular path. Okay, and another component of the velocity vector V cos theta acts along the B vector. It creates the linear motion of the particle. That's why the particle moves in a spiral path. Okay, moves in a spiral path. Now the radius of the particle path or circular path is r is equal to mv sin theta by b into q. It can be derived in the previous way. You can derive the r is equal to mv sin theta by pq. Okay, and you know that the time period or cyclotron frequency or angular frequency of the charged particle do not depend on radius of the path and velocity of this charged particle. That's why the time period t is equal to 2 pi m by bq. Now the pitch of the charged particle. What is pitch? Due to the one circular motion or full rotation of the charged particle, the linear motion or linear distance covered by the charged particle is known as pitch of this charged particle. Therefore, pitch of the charged particle is equal to the time period of the charged particle into linear velocity v cos theta. And now, substituting the values of capital T and V, we can write that P is equal to 2 pi r cos theta. This is the expression of pitch of the charged particle. Okay, thank you for watching my video, and next video I can explain or I shall explain the working principle of cyclotron. Okay, thanks again and have a good day.